Hello my dear students, welcome back to your favorite and India's most affordable learning platform, Physics Wala. So in the last session of motion in a plane, we have started the projectile motion where we just covered the basics of the projectile motion. So whenever you throw an object with some angle theta, so then it travels in the x direction as well as in the y direction, alright? So then we have different parameters. So what is the maximum height reached by the body, the projected body, and what is the horizontal range, and what's the time taken, which is called the time of flight, and we have derived the formulas for that. And at any point on the projectile motion, how do we find the velocity at any point at some general angle theta? So that's how do we find the velocity? That also we have seen in the last class, right? And then so in today's session, so we are going to continue with the same topic, that is projectile motion. So where in today's topic we'll discuss the equation of trajectory and what is the relation between range and maximum height, and where the maximum when the range will be maximum. So all these things we are going to discuss in today's session. So as usual, for the next 1 hour, just be with me, avoid all the disturbances around you guys, and at the end of the lecture it's very important to prepare your own short notes, right? Chalo. So with a very positive energy, let's start with the today's session. So before going for the today's topic, so let's just recap the previous class topics. So where we have seen, so when a body is thrown with some angle, let's suppose like this, so then it moves like this, right? So this is in the x direction and this is in the y direction, right? So then, so you have thrown with some velocity u, let's suppose, so then let it be the angle theta. So then this is going to be u cos theta, and then this is going to be u sin theta. Okay, so then the range from here to here, the horizontal distance covered by the body is called range, and then this is called the h max, and the total time taken is called the time of flight. So at any point on the projected body, so the ux, the horizontal component of the velocity u cos theta, it remains constant, so it will never change. So that's why throughout the projectile motion, so the acceleration in the x direction is going to be 0. So these are the basic things that we have already seen, right? And so what is the time taken by the body to reach from here to here? So that's called the time of flight, so which is nothing but 2u sin theta by g. So which is 2u sin theta by g. So this is 2u, just a minute guys, so this is going to be 2u sin theta by g. Yes, fine. Next, yes, fine. Chalo. So now, so we have also got what is the h max, so the maximum height, so which is u square sin square theta by 2g. And then, so what is the range, so which is u square 2 sin theta cos theta by g, right? So and these formulas we can also written in this form. So what is that? So 2 into, so u sin theta means, so velocity in the y direction by g, and then so this is u sin theta whole square, which is uy whole square by, so 2g, and then so this I can write it as, so 2 into ux into uy by g. Okay, so these are the simple formulas that you have to remember. And one more thing, so at any point if you have to find the velocity, let's suppose at this point, so the vertical velocity it keeps decreases while it goes up, right? And at the final, at the highest point, the vertical velocity vy will become 0, but the horizontal velocity will remain same, which is u cos theta. So this point also we have seen. Let's suppose if you need the velocity at this point, let it be the point P. So if you need the velocity at that point P, so the horizontal component remains same, which is u cos theta, but the vertical component changes, so which is nothing but u sin theta is the original one, and it decreases by minus gt, right? So this also we have seen. If you need the speed there. So simply the magnitude of velocity is a speed, so which is square root of u cos theta whole square, so plus, so u sin theta minus gt whole square, u sin theta minus gt whole square. So this is a point. Clear? Right. So if you need what is the angle of projection there, so that is the angle, so that is vy by vx. So this is the complete basics of the projectile motion that we covered in the last session, right? So now, so coming to the today's topic, so I guess I gave this question as homework for you guys in the last session. So hope you guys solved. So but I couldn't see any comments related to this question. So I think you may not solve, right? So whenever you solve the question, just if I give it as a homework, just put it down in the comments. No, I'll get to know whether you are solving it correctly or not. A body is projected with a speed 30 meters per second at an angle 30 degrees with the vertical. So see here, so this is a body projected. So let's suppose, so with the vertical they said 30 degrees. So this is 30 degrees. So obviously this is going to be 60 degrees, right? So then find the maximum height. So this is 30 meters per second. So now we can write the components. What are the components? So the ux is going to be u cos theta. So 30 cos 60. Yes or no? This angle is 60 we should take. So cos 60, which is 1 by 2. So 30 into 1 by 2. So which is 15 meters per second. And then what is uy? Uy is u sin theta. So 30 sin 60. So what is sin 60? Root 3 by 2. So which is nothing but 15 root 3, right? So the ux is equals to 15, and then uy is equals to 15 root 3. So meter per second and meter per second. So now the formulas you know, right? So first they asked us to find what is the maximum height. So the first one, the h max, which is equals to, so uy square by 2g, that's it. So I'll just directly write like this. So uy square by 2g. So what is uy square? So uy is 15 root 3. So which is 15 root 3 whole square by 2 into g. Take the g value as 10 as they mentioned. So consider this as 20. So this is going to be 225 into 3 by 20, right? So just do the calculation. And then next we have the time of flight. So what's the time of flight? So 2 uy by g. So which is nothing but 2 into, so what is uy? So uy is 15 root 3 by, so 10. So this is going to be, so 2 1s are 2 5s are 5 1s are 5 3s are. So which is 5 root 3 seconds. And then, so the third one, it's going to be the horizontal range. So the r is equals to 2 ux uy by g. So 2 into ux 15, uy 15 root 3, and then by g. So 10. So 2 1s are 2 5s are 5 1s are 5 3s are. So which is going to be 45 root 3. So clear? So this is just the basic question, right? So don't waste much time here. So that's a very simple question. So and again this question also I gave it as a homework in the last session, right? So what's the question says? The u initial velocity is given as 5 I cap, consider that as I cap, so plus 10 j cap. So then here, so if it is the velocity, so then shall I say the x component of the velocity is 5, the y component of the velocity is simply 10. So now you can find the answers. So the first question, time of flight, so which is 2 uy by g. So 2 into what is uy? 10 by g, 10. So 10 10 cancel, it's going to be 2 seconds. So and then option question B, maximum height. So what's the maximum height formula? The h max is equals to uy square by 2g. So what is uy? Uy is 10 into 10 by 2 into g, 10. So 10 10 cancel, so this is going to be 5, right? Chalo. So correct only, right? So uy square 10 10 by 2g, 2 into 10 is fine. So then C, so that's a range. So the range is equals to, so 2 ux uy by g. So 2 into what is ux? 5, and what is uy? 10 by g. What is g? 10. So then it's going to be 2 into 5, 10. Clear? So the basic question, that's it, formula based one, right? Chalo. So let's move further. So then what is the relation between the range and H max? So see here, we have got the range formula 2u square sin theta cos theta by g, sin theta cos theta by g, and we have got the H max is equals to u square sin square theta by 2g, right? So let it be the equation number 1, let it be the equation number 2. So now what I am doing is, let's divide, so 1 by 2, okay? So then r by H max, so let's write H max as h. So r is equals to what? 2u square sin theta cos theta by g whole by H max, which is u square sin square theta by g, 2g, sorry, right? So then yes, correct. So yes, fine. So then u square cancel, so sin square theta, so here sin theta cancel, so from here, so g cancel, so I can write like, so what is left, so 2 here cos theta by 1, so into, so here it 2 by, here u square cancel, sin theta, yes or no? So then I can write the, see here, so I can write r by h is equals to, so 2 into 2, 4 cos theta by sin theta, right? So from here I can write this as, so the 4h r into, so let's send this sin theta and cos theta to this side, so which is equals to 4h, okay? So now from here I can write r tan theta is equals to 4h. So this is a relation between, so the range and maximum height, so where r tan theta is equals to 4h, guys. So or else if you want, you can write this way also. You can write here r by h is equals to 4 cot theta, r is equals to 4 h cot theta, you can write r by h is equals to 4 by cot theta also you can write. So r by h is equals to 4 cot theta, this also you can write. Clear? Understood this point, everyone? Sure. Done? Any doubts here? So this relation is very important to solve the questions, okay? So keep it in mind. R tan theta is equals to 4h, or r by h is equals to 4 cot theta, anything is fine, okay? Chal. So let's move further. So the simple question, pause the video and try it on your own, guys. So what's the question says? The horizontal range and maximum height of the projectile are equal. So the horizontal range r is equals to, so the maximum height h, both are equal. So the angle of projection of the projectile, so they are asking what is the angle of projection of the projectile. See here, if r is equals to h, so we know the relation between r and h, so just now we have seen. So r tan theta is equals to 4h. Just now we wrote the r tan theta is equals to 4h, yes or no? So now from here, in place of r, shall I write h? In place of r, shall I write h? So tan theta is equals to 4h. So here h cancel. So from here I can write the tan theta is equals to 4. So from here theta is equals to the tan inverse of 4. So the theta is equals to the tan inverse of 4. Clear this part? Any doubts related to this? Quickly. So no, chal. So the option tan inverse of 4. So which is option, this one, B. So next question, what's the question says, see here. A particle is projected with a vertical velocity, with a velocity v such that its range on the horizontal plane is twice the greatest height attained by it. So they are saying that the range is twice the greatest height attained by it. So greatest height means the maximum height. So range is equals to 2 times the h. Okay. So then the range of the projectile is given as, so let's write r is equals to 2h. So now we know that, so the 4h, the r tan theta is equals to 4h. This relation we already know. So now what I am doing is, in place of r, let me substitute 2h. Okay. So try to understand the concept, guys. Just in the given question, they said that the range is, so the range is, so twice the greatest height attained by it. So the range is 2 times the maximum height. Okay. So r tan theta is equals to 4h. This standard result we already know. In place of r, I am writing 2h. So now h cancel. So 2 ones are 2 2s are. So from here, the tan theta is equals to, so let's write 2. So let it be. So then what they are asking in the question, they are asking us to find what is the range of the projectile. So what is the range formula we know? So the range is equals to 2u square sin theta cos theta by g. Yes or no? So now you know the u value. So in the question they said that it's v. U is equals to v. It's thrown with some velocity v. So in place of u, you can substitute v. So but we have to find sin theta cos theta. That's the thing. So I know the tan theta. So what I am doing is, let's use the basic trigonometry. So let's consider in this right angle triangle, let it be theta. So they said tan theta is equals to 2. 2 means 2 by 1 I can write. What is tan theta formula? Opposite by adjacent. So for theta, the opposite is 2, the adjacent is 1, the hypotenuse will be square root of 2 square plus 1 square. 2 square is 4 plus 1 square is 1. So 4 plus 1, 5. Yes or no? Simple Pythagoras theorem I am using. So I got the complete sides of the right angle triangle. So then I can say what is sin theta from here. The sin theta is equals to opposite by hypotenuse. So root 2 by root 5, and cos theta is equals to adjacent by hypotenuse, which is 1 by root 5. Yes or no? So now, so r is equals to 2 into, in place of u, I am substituting v square sin theta 2 by root 5, cos theta 1 by root 5. So by g. So r is equals to 2 into 2. So 4 v square by root 5 into root 5, 5 into g. So the range is equals to 4v square by 5g. So the range is 4v square by 5g. The simple one. Alright? Clear? Chal. Next. So let's see the next question, guys. What's the question says? See, whenever the question appears, just try to do it on your own. Pause the video, try to do it on your own. Okay. A projectile is fired at an angle of 45 degrees with the horizontal. So elevation angle of the projectile at its highest point as seen from the projection of point of projection. So see here. So what's the question says here? First, this is a, so x-axis, y-axis. So a body is projected, a projectile is fired at an angle 45 degrees. So initially it is fired at an angle 45 degrees. Fine, with the horizontal. So elevation angle of the projectile at its highest point. Elevation angle, what does that mean by elevation angle? To the highest point. First, on this projectile path, the highest point is where the maximum height is attained. This is the highest point on the projectile. Yes or no? Highest point is nothing but where the max height is maximum. So they are saying, see here, the elevation angle of the projectile at its highest point from the point of projection. From the point of projection. So the, what is the elevation angle? You know the elevation angle, right? What does it mean by elevation angle? This one. Let's suppose I am standing here, I am observing some object which is like above me, some height above me. So then whatever the angle that I am making with respect to the horizontal, that's called the angle of elevation. You studied in the grade 10th, right? So where in applications of trigonometry. Yes or no? So the same thing, the angle of elevation to the highest point from the point of projection they are asking. So let it be alpha I am considering. Let it be alpha I am considering. So then in this triangle, see here, this is going to be the right angle triangle. So this color one. So this total thing, so this is going to be the right angle triangle. Yes or no? So now see here, so this is high h max, so to exactly the half, so this is going to be half the range. Yes or no? Yes or no? So now from here what I am doing is, from this triangle let's write what is tan alpha. So the tan alpha is equals to opposite. So what is opposite? So the h max. Yes or no? Opposite is h max by r by 2. So opposite by h max, which is r by 2. So now here I know what is this angle, right? So what is the angle of projection? Angle of projection is 45 degrees, right? So the theta is equals to 45 degrees. So then we know that the r tan theta is equals to 4h. R tan theta is equals to 4h. So from here, shall I write r into tan theta? So tan 45 is equals to 4h. So from here, so let's write r. So tan 45 is 1. So r is equals to 4h. Shall we write? R is equals to 4h, right? So from here, so tan alpha is equals to, so h, let it be in place of r, let's write 4h by 2. So the h cancel. So the tan alpha, which is equals to, so this is going to be 2. Yes or no? Sorry, wait a minute. So the tan alpha is equal to h max by, this is r by 2. Yes. So then this is going to be the tan alpha is equals to 2h by r. 2h by r, right? So from here, so I can write tan alpha is equals to, so 2h in place of r, I am writing 4h. So h cancel. So the tan alpha is equals to 1 by 2. So from here the alpha is equals to tan inverse of 1 by 2. Yes. So just check the answer. Tan inverse of 1 by 2. No, no, no. Option D is the correct one. Clear, everyone? Understood this point? So chalo. So let's move to the next concept. So that is the maximum range. So when the range will be maximum, so with what angle if you throw a projected body, so that its range will be maximum. That means in the horizontally, so the maximum distance it will reach. That's the maximum range, right? See here. First, what's the range formula? So the range is 2 u square sine 2 theta, sorry, u square sine 2 theta by g. U square sine 2 theta by g. So r is a function of theta. Yes or no? U is the initial velocity which is constant, and g is the acceleration due to gravity which is constant. So this theta, the projected angle will vary. Yes or no? So now, so for which angle we are going to get the maximum range? That's what we have to find. See, if y is a function of x, in the basic maths we have seen, if y is a function of x, so then the dy by dx is a maxima condition. The dy by dx is equals to 0. So this is a condition for maxima. So here also I have to find the maximum range. So then for which the dr by, with respect to what? Theta, for which angle the maximum range occurs, that I have to find. So therefore the dr by d theta should be equals to 0. So then what is d by d theta of r? What is the range? Range is u square sine 2 theta by g is equals to 0. So from here I am writing, so u square by g is the constant, let's take it out, and then d by d theta of sine 2 theta. So d by d theta of sine 2 theta, so is equals to 0. So now from here, so I can write u square by g of sine 2 theta. So differentiation is cos 2 theta, and again this is differentiable. 2 theta is differentiable, so 2 theta differentiation is 2, which is equals to 0. So from here let's send all the constants to that side, so that so cos 2 theta will become 0, because u square by g you send it to that side, 2 also you send it to that side, it becomes 0. So then the cos 2 theta must be equals to, so the cos 90 degrees. So the cos 2 theta is equals to cos 90 degrees. So from here I can write 2 theta is equals to 90 degrees. So from here the theta is equals to 40 5 degrees. Yes or no? So that means if you throw a body with an angle 45 degrees, so then its range will be maximum. So this is a standard result that you have to remember. So what's that? So for 45 degrees, so the range will be maximum. So the range will be maximum. So if they ask you what is that maximum range? What is that maximum range? We have got R is equals to sine 2 theta by G is a formula. So now R max, let's write R max is equals to U square sine 2 theta. In place of theta, what we should write? 45 degrees, because the maximum range occurs for the 45 degrees. Yes or no? So by G. So R max is equals to, so U square sine 90 degrees. So sine 90 is nothing but 1. Yes or no? By G. So therefore the R max is equals to U square by G. So this is U square by G. So therefore, so two standard results that you have to remember from here. So for theta is equals to 45 degrees, for theta is equals to 45 degrees, so the range will be maximum. The range will be maximum, and then that maximum range which is going to be U square by G. That maximum range is U square by G. Clear? Understood? This part, everyone? Clear, clear, clear? Chalo. So let's move further. So the same range for the angle of projections theta and 90 minus theta. So let me show you here. So let's suppose y-axis, x-axis. So then you projected a body with some angle theta. Okay. And then you projected another body with some angle, so 90 minus theta, let it be 90 minus theta. Okay, so then, so the ranges will be same for the angles theta and 90 minus theta. So for example, if I say, if one angle is 30 degrees and for 60 degrees, so if those two angles are complementary, so then their range will be same. For 30 degrees and 60 degrees, the range will be same. So for theta and 90 minus theta. So if one is 30, the 90 minus theta means 90 minus 30, which is 60. So for 30 degrees and 60 degrees, the range will be same. R. So if I say one angle is 15 degrees, so then for 75 degrees, the range will be same. For theta and 90 minus theta, the range will be same. Remember this. So for theta and 90 minus theta, the range will be same, but the maximum height differs. But H max changes. H max changes. Remember this point. So the range is same. For if you throw an object with some angle theta, so let's suppose this, it follows like this, it path. So then 90 minus theta, some other angle. So then it followed this path and the range will be same. That means horizontally it reaches at same distance. But vertically, when you throw with some angle theta, the maximum height reached by it is, let's suppose, the height reached when the angle is theta. And the height reached when the angle is 90 minus theta is this one. Right? So then the relation between these heights is given as height by theta, height at theta angle, then height reached when thrown with some 90 minus theta. So the relation between these two is given as tan square theta. So this is also one of the important result you should remember. Okay, so their ranges will be same, but their heights will differ. So their heights ratio I have given here. H theta by H of 90 minus theta is equals to tan square theta. Clear, everyone? Chalo. So let's move further. So see here, so what's the question says here? For angles of projection of a projectile, so 45 minus theta and 45 plus theta, the horizontal ranges described by, see here, one is 40 minus theta. Okay, so let it be the first one. So let it be some angle alpha. So then the other angle which is given as 45 plus theta. So the other angle shall I say, so for Other angle 90 minus alpha. What is 90 minus alpha? 90 minus what is alpha? 45 minus theta. So which is nothing but 90 minus 45. So plus theta, which is nothing but 45 plus theta. Yes or no? So if I consider this as alpha, 45 minus theta, I consider this as alpha, and then so 90, this is becoming the 90 plus alpha, sorry, 90 minus alpha. This is alpha, so this is becoming the 45 plus theta is nothing but 90 minus alpha, right? So that means for alpha and 90 minus alpha, the range will be same. For alpha and 90 minus alpha, the range will be same. Yes or no? Already the theta is given, that's why I am considering the first given angle as alpha. So then I am checking what is 90 minus alpha. So 90 minus, so 45 minus theta. So then I got 45 plus theta, which is nothing but this is the angle, which is 90 minus alpha, 90 minus alpha. So they both are like for complementary angles, right? So that's why the range will be same. So that's why 1:1. They are asking that only, right? The horizontal range described by the projectile are in the ratio. Okay, 1:1. So you can write here for complementary angles of projection, the range will be same. For complementary angles of projection, the range will be same. Right? Clear? Next. So see here. So next question, two particles are projected with same initial velocities at an angle 30 degrees and 60 degrees. So with horizontal, then see here. So 30 and 60 are complementary first. So 30 degrees and 60 degrees. So they both are complementary angles. Yes or no? Sum of the two angles is 90 degrees. So they are said to be complementary, right? So then if they are complementary, so the range will be same. So but H max will different. So their heights will be equal, no? So the ranges will be equal, yes. The time of flights will be equal, no? So the ranges will be different. Ranges will be same. No. Option B is the correct one. Done? Sure. So now the important part, that is what is equation of trajectory. So the trajectory means path followed by the projectile. So the trajectory is nothing but the path followed by projectile is called the trajectory. So then let's write the equation for the trajectory. So the equation of trajectory we say. See here. So I am considering the x direction motion of the body and I am considering the y direction motion of the body. So we already know that in the x direction, so let the initial velocity, the initial velocity is u cos theta, because the body is thrown with some velocity u, so at an angle theta with respect to the horizontal. So then the u cos theta is a horizontal component of velocity, u sin theta is a vertical component of velocity, right? So then, so the distance covered in the x direction is going to be the range. So the acceleration in the x direction is going to be 0. Yes or no? So now I am using, so the Sx is equals to uxt plus half axt square. Yes or no? So from here, so the acceleration in the x direction is going to be 0. Yes or no? So that's why this whole term will become 0. So the let the distance covered in the x, so let it be, let's write some x distance. Let's write some x distance. So where this x distance is equals to ux. What is ux? U cos theta into, so let the time taken be t. Let the time taken be t. So the equation of projectile, we are trajectory at some any general point, any like, see the trajectory equation, let's suppose if we have to find here. So then we can say that it covered some x distance till here, yes or no, and some y distance till here. Or else if you need the trajectory here, so some x distance till here, some y distance till here. So that's why the distance covered in the x I am considering as x. So for here to reach here, so let's suppose it's taking some time t is equals to t. So consider some time t is equals to t here. Okay. So now let's see for the y direction. So we have got the initial velocity in the y direction is u sin theta, and we know that the acceleration in the y direction is going to be minus g, and to reach from here to here, so let's suppose this is a some point p x comma y. So in the y direction it has reached some distance y, right? Chal. So then anything else? So the time taken from here to here, let it be t is equals to t. So now what I am doing is, so let's write the equation. The sy is equals to uyt plus half ayt square. Just I am writing the s is equals to ut plus half at square in the y direction. That's why I am keeping y. Okay. So the distance covered in the y is equals to y. So y uy is u sin theta. So into t. So in a, in place of a I am writing minus g. So let's write, so minus g. So and then let's write t square. So let's do some calculations here. So let me eliminate the t term. So the trajectory, the path followed by the trajectory. So independent of t we have to find. Independent of t. So there should not be any time term. Independent of t, there should not be any time term. Okay. So for that what I am doing is, so the t is equals to, shall I write x by u cos theta here? The t is equals to x by u cos theta. So then I am writing here, so y is equals to u sin theta into, so what is x t? So t is equals to x by u cos theta, let it be minus half g into, so in place of t I am writing x by u cos theta whole square. Okay. So from here let me write, so u is equals to y is equals to u cancel, x here sin theta by cos theta, so which is tan theta. So the x tan theta minus, so half gx square here, g into x square by 2, here u cos theta whole square means u square cos square theta. So this is called the equation of trajectory. This is called the equation of trajectory. So everyone, very important. So just try to write along with me without seeing. See what is the equation of trajectory? So the y is equals to x tan theta, so minus gx square by 2u square cos square theta. So by 2u square cos square theta. So this is a equation of trajectory. Everyone should remember this. Okay. And so this equation you can also write it as, so this equation you can also write it as y is equals to, so x tan theta minus, so let me write, so gx square, so by 2u square, here in place of 1 by cos square I am writing secant square theta. Okay. So then what we can do is, so y is equals to x tan theta minus gx square by 2u square, in place of secant square theta, so I can write 1 plus tan square theta. In place of secant square theta I can write 1 plus tan square theta, because secant square theta minus tan square theta is equals to 1. So from there secant square theta is equals to 1 plus tan square theta, trigonometric identity. So either you can use this equation in terms of completely tan, or in terms of tan and cos. This is a one more equation of trajectory. Clear everyone? Clear? Understood? Chal. So let's go for the next one. So that's what I wrote here. The path followed by the particle, here the projectile during its motion, is called its trajectory. The path followed by the projectile is called trajectory. So the equation of trajectory is given here. So y is equals to x tan theta minus gx square by 2u square cos square theta. So other forms of trajectory, x tan theta minus gx square into 1 plus tan square theta by 2u square. So now I am giving you the homework for the next class here. The class is not over yet. See here. So write equation of trajectory in terms of range. Write equation of trajectory in terms of range. In terms of range. Okay, so this is a homework, guys. So just write your answer in the comments. Okay, so if you are not getting, I'll explain it in the next class, but first try it on your own. Okay, sure. So see the simple question here, it is given. So what's the question says? So y is equals to, so the equation of the projectile is given, y is equals to root 3, here x outside it is, so gx square by 2. So the speed and angle of projection are, see, so y is in terms of x, which is nothing but it is in the form of equation of trajectory. So what is the equation of trajectory? So y is equals to x tan theta minus, so gx square by 2 u square cos square theta, so by 2 u square cos square theta. So now comparing the above equations, so shall I say that in place of tan theta we have root 3, so tan theta is equals to root 3, yes or no? In place of x, x is there, in place of tan theta root 3 is there. So from here tan theta is equals to tan 60, and then so from here the theta is equals to 60 degrees, yes or no? So this part is clear. And so again the angle of projection we got 60 degrees. 60 degrees is there in only one option, you can directly proceed for this. So let's find speed also, they are asking speed also, right? So how do you find the speed? So again compare gx square is there. So in place of 2 u square cos square theta, in place of 2 u square cos square theta we have 2. So therefore 2 cancel. So then the u cos theta whole square is equals to 1. So from here, so what is u cos theta whole square, u into, so let's write u square into what is cos theta, the cos 60 whole square, cos square 60 degrees is equals to 1. So u square into cos 60, which is 1 by 2 whole square, which is equals to 1. So from here, so u square is equals to 1 by 4, if you send it to that side 4. So therefore u is equals to 2. So the speed is 2 and the angle of projection is 60 degrees. Done? So very simple question. Chalo, so let's move for the next question. So what's the question says? So a projectile is fired from the surface of the earth with a velocity of 5 meters per second at an angle theta with the horizontal. Another projectile fired from another planet with a velocity 3 meters per second at the same angle as follows the same angle follows a trajectory which is identical with the trajectory of the projectile fired from the earth. So the value of acceleration due to gravity on the planet. See here question. So first the projectile is fired from earth. Consider the projectile is fired from earth. So with some angle theta. Consider the projectile is fired with some angle, let's suppose with the horizontal it is fired with some angle theta. So with the initial velocity 5 meters per second. So then let's suppose the body has followed this trajectory, yes or no? So now there is some other planet. So again another projectile is fired here, another projectile is fired, so with a speed of 3 meters per second at same angle. So here and here the angle is going to be same, theta, yes or no? So and it follows the same trajectory, see here. So the trajectory which is identical with the trajectory of the projectile fired from the earth. So that means here the trajectory equation, here the trajectory equation, both are same they are saying. So but here the acceleration due to gravity is g. If the planet changes, the acceleration due to gravity will become g dash. That's the only thing. So therefore on the earth, now I can write the equation of trajectory. What is the equation of trajectory on the earth? So the x tan theta minus g x square by 2 u square. In place of u, let's write 5 square. So cos square theta. So the theta is same. So in the planet, on the planet, so the let the y is equals to, so x tan theta, so minus, so g dash, let's consider the new acceleration due to gravity on the planet is g dash. So g dash x square by, so 2 into 5 whole square. So into here not 5. So here it is 2 into what's the velocity here? 3. So 2 into 3 whole square, and the angle is same. Let's write cos square theta. So they are saying these two are equal. So now let's equate those two. So the x tan theta minus gx square by, so 2 u square is what? 5 square cos square theta, which is equals to x tan theta minus gx square by 2 into 3 whole square into cos square theta. So the x tan theta cancel, minus also gets cancel, gx square cancel, cos square theta, sorry. So here g, here it is g dash. So here x square cancel, so 2 cancel, cos square theta cancel. So I left with, so g by, so the 5 square which is 25, which is equals to g dash by 3 square 9, right? So from here, so what we need, so the g dash we required, so the g dash is equals to g into 9 by 25. So options how they are giving, so let some values are there. So let's take the g value as 9.8, they clearly mentioned. So that's why they consider this as 9.8 into 9 by 25. Okay, so do this calculation, you'll get the g dash value. Okay, clear everyone? So simply the basic calculations, so both the equations of trajectory are same. So g by 5 whole square, here the only thing remained, here g dash by 3 square, which is 9. So we need g dash, so which is nothing but g into 9 by 25. That's it. So then whatever the answer, so just comment it. Done? Understood guys the procedure, how to solve these kind of questions, right? Chalo. Next. So the remaining part we'll see it in the next session. So tomorrow's session, so we'll see the projectile from some height and projectile with some angle from some height. Okay, so those two topics, and the projectile motion on inclined plane, that also we'll see. So tomorrow is going to be the last lecture of your motion in a plane. So after this we'll start and if time permits we'll see the distance of closest approach. So that also we have to cover tomorrow's session. Okay, so the tomorrow's session is going to be bit lengthy session, and then after tomorrow's session the next chapter will start Newton laws of motion. Okay, so till then keep studying. All the very best guys. Bye, take care.